data into the appropriate data cube architecture. So you can see from the down, this is the frame. So the whole Digital Earth Africa platform is based on the data cube, the open data cube architecture. And as you can see, all those data and processing that are available into the Digital Earth Africa platform are focused into the various SDG goals. And you can see the goal number 2, 6, 9, 11, 13, 14, and 15. The one that we are interested on today is the goal 13, which Digital Earth Africa has provided a lot of tools and notebook that will help to address the climate action. On the Digital Earth Africa platform, you could see that there is a Digital Earth Africa Climate Action Toolkit that is really dedicated to anything that concerns climate action in Africa. So we were able to categorize all the action into mitigation of climate change, climate adaptation, monitoring, evaluation, and reporting on climate action, and creating customized output using multiple Digital Earth Africa products and services. So let me go straight to one of the particular notebook that is related to urban extent, so that we could view exactly what we are talking about. If I may briefly summarize again, the Digital Earth Africa, based on the data cube structure, is providing data freely. You know, one of the problems that has been identified is the availability of data. So that one is settled. Digital Earth Africa is providing the data, is providing the platform to process the data freely through the Sunburst, is the Jupyter environment that allows you to process the data and then get the results that you could download. So no more need of gathering data from here and there, purchasing data at high cost, all those things. And also the infrastructure, the cloud infrastructure is made available freely for you to process your data and get your results. So a certain tools to allow you to have to take good decision. So coming back to the notebook on the Sunburst, for people that who have gone through the e-learning platform of Digital Earth Africa, you have registered and see that there's a lot of notebooks that target different feeds that are available that you could customize and use directly without paying any cover. So one of them is about urban extent. So with the rate of growth in the city and town, urbanization, you could notice that we have some challenges. We have been facing some challenges, and we need to know exactly what is going on, how the town is growing towards some other extent that, and all those congestion created by the extension of the urban area may cause pollution and a lot of various problems. So let's see through this notebook how you can measure this extent on a particular area that you could identify. So this particular notebook falls into the category of mitigation and of climate change, and also a way of monitoring, evaluating, and reporting on climate action. So here the data used, which is also a free data available on the platform that you can get, is a geomedian image based on the Sentinel-2 imagery. So the geomedian gives you, for a whole year, all good pixels. So there's no bad pixel at all. So you can make correct observation directly from a geomedian image. So here we like to see what happened between 2018 and 2021. So the difference in urban extent between the two periods will be calculated along with a map highlighting the location of urban growth hotspot. So here firstly, we will be loading the Sentinel image use a NDC, the Enhanced Normalized Difference in Previous Surface Index, which is an index that is mostly used in urbanization. Get a threshold and then compare the urban extent between the two periods of time that we chose. So basically, we have to note that the notebook are there free to be used. What you need to do is to get your area of interest, whether you are in South Africa, in Kenya, Uganda, Nigeria, anywhere. So you just pick your area of interest through this a line of code. So from the notebook, you just identify where to. I will later share those notebooks that we explore so that you can, at your own convenience, pick the area of interest that you know very well and observe the urban estate. So you pick the large and long, and then you choose a buffer that will cover around the area of interest. And the baseline, the two periods of time that you want to see to compare the extent. So basically on all the notebook, you have to adapt it to your region of interest and then run it. Simple. So that does not require a very high level of understanding of Python, because all we have there in the notebook are in Python. So when you load the geomedian, that's what you see. For instance, that lat and long that we pick is a region in Ile-Ife. So it's the central point of Ile-Ife, then we created a buffer that will cover the whole Ile-Ife. So that's for the year 2018 and 2021, basically. So you have those two images that you can see exactly what happened between these two periods of time. You will notice that from in 2018, you can see here the urban extent here. And in 2021, you should notice that around this area, you could see new construction, new development, and compared to 2018, which is a little bit dry. So around this line, also, you will notice that there are new construction, new building, and also around this area, new installation, maybe agricultural area has been developed around this area as well. So those are visual observation that you could directly made based on what the GeoMath data is giving you. So the next slide plots the NDCs that shows you based on the NDCs vary from -1 to 1, and then you could see the urban extent on those two periods. when you create a threshold, the threshold say from these indices at minus 0.25, anything superior to minus 0.5 should be considered as urban area, and all the others are not urban. So based on that threshold, you can see what happened here. All the urban area are in yellow and the rest are in purple. So that shows you clearly based on compared to the previous image on the geomap that I've shown before, that there is extend on urban area along these places, and also somewhere around here. So all those observations need actually to also be confirmed with terrain. It should be an area that you know very well, and then you can justify what really happened. So the notebook also allows you to calculate exactly to see between 2018 and 2021 what was the extent in kilometer, what happened between the 2 years. You will see that urban extent in 2021 you have 95.02, and in 2021 102.14 kilometers. So this map now is showing you the area where you notice urban growth, the area where there is urban decline, and the places that nothing happened at all. So basically, this notebook can be run in 2 minutes, and then you get all these results that you can convey to the decision-making people to take decision according to real data and analysis that will be useful for the development of the country. So that said, we can go a little bit further and see the time series analysis of temperature on the same location. So we keep the same location in Ile-Ife, the same lat and long, the same buffer, in the same time. The period, the time series will be 2018 to 2018. So when you run this particular notebook with the same parameter, you could observe based on also the geomap, you have plot the ERA 5 image and the Landsat 8 surface temperature. Those are the data that we use for this particular analysis. So you can see what happened in terms of statistical data, in terms of temperature, that, okay, this, the surface temperature, the central part of Ile-Ife, what happened here, the temperature there was a little bit concentrated at the central part in 2018. And in 2021, that temperature goes across and were more expanded to various areas. So due to concentration and extension of people around the place. And then you will be able to plot some graph to see the monthly trend in temperature. And you could notice that from July 2018 to July 2021, there is an increase in the temperature around these places. So that basically allows you to plot some statistical graph and to see what really happened in correlation with the previous book that show the urban extent on that. So when there is urban growth, for sure, that affect the number of people in this particular area, and then you could see that the temperature will be raised in that area. So the exploration analysis conducted in this notebook allow us to visualize and examine the trend and seasonal pattern. We will need for sure to conduct further statistical tests to determine whether any observed trend could be considered significant, meaning that after all, the terrain is compulsory to confirm, to ascertain certain results and all that. So if you have this link, I will post this Google Drive. The two notebooks are inside. So if you like to run them, you could see based on the region that you have identified that well, what happened into a particular area that you know very well. Then you can apply the two notebook and get the result. You can as well extend the period of the analysis and go back to some years back to observe during the long-term period what really happened. The good thing is that the platform, all those platforms allow you to get archive data. We are talking about data that are available in AWS in South Africa. So you can make use of them, extract your results, so and present it accordingly for the appropriate use. So that being said, I think that will be all for my presentation. Acknowledge to all these good people that have been working together for the project Digital Health Africa, a certain number of partners and implementing partners. Thank you. Merci beaucoup for listening.
Thank you so much, Adimo. I am lucky to be in this meeting. I should actually be hanging around somewhere, but I think we ended quite early. Please disregard the timer we have on the screen. It's a little bit not correct. It's not correct in particular. And then I think we have about 9 more minutes or 8 more minutes. Sorry. Yeah, I think we have about, am I mistaken, 8 more minutes before the end of this particular session. And since we were able to end early enough, I think it would be good for us to ask some questions, and then we can as well answer them, especially that pertains to this topic. Let's have some questions. Personally, I have one, and then I know some of us will have questions as well. So participants, if you have questions, I know that, sorry, I'm trying to identify a rapporteur now for the session. I know Rose is in this room, and Rose will be happy to take our questions and moderate the session for, or moderate the question and answer session for this particular workshop. Thank you, Rose. Rose, are you there?
Yes, I'm here.
Great. Okay, thank you so much. I would just want you to help us moderate the questions and answers. And once we are done with the questions and answers, then the rest of us can move to the, or we can all move to the main room. We can go back to the main room. Thank you, Rose.
So right now I'm trying to put in the chat some useful link for you to know exactly what is available. If the data available covers your place, you could just check. I've shared the Google Drive link for you to access the two notebooks that were used for the presentation. And if there's any challenge, or you feel free to talk to me through mail.
Thank you, Adam. I think, let me ask my question. And
Yes.
my question was that when I saw the particular notebook you used, I discovered you used a point, you dropped a point coordinate. And I was imagining that if I should have a shapefile or if I should have a polygon, can I be able to supply that data into this notebook as well and then do this particular analysis for a specific region? Say if a north, I'm not sure if there's anything like that, if a north or if a south, you understand what I'm saying? Thank you.
Yeah. Okay. I think I can answer you. You can integrate your shapefile directly to the platform and get the data just based on the shapefile. Is possible.
Thank you so much. Will you be happy to show us that if you have a sample? If not, don't worry. We can just migrate to the main room once you're done.
Okay, I don't have. It's just a code, a line of code that you use to load the appropriate data based on your shapefile. I can share that with you. If there's a forum where I can share the link of those line of codes, I could do that.
Okay. No problem.
I have another question. Sena?
Hello.
Yeah, I have another question. You talked of Sentinel-2, and it has different bird resolution. Which bird specifically are you using?
Sorry, come again.
You talked of using Sentinel data, the track data.
Okay.
Sentinel-2, and I understand that it has several band resolutions. Which bird specific do you intend to use?
Okay. Well, on Sentinel-2, we have available all the bands that concern Sentinel-2. And in fact, the Sentinel-2 data is processed at a certain level. Also, it depends on what you want to do. The indices that you want to use, that will determine the bands that you use. Just note that all the bands are available for use. If it's a near-infrared or all those bands are available. So the formula of the indices you are using will determine which band you are picking from the Sentinel data. I don't know if I answered the question.
Okay, for instance, in your presentation, you were talking about urban, right?
Yep.
So if my interest is to know if you intend to use that bird with 10 meter resolution, how will you be able to distinguish the built up areas within the town using now that 10 resolution?
Okay. What I will say to distinguish what I use is a geomedian image data set. You know, if you go back quickly, I can show you. It's a geomedian, and I told you that the geomedian is an imagery that is based on Sentinel-2, which selects all the good pixels for a whole year. So there's no cloud problem. You don't have cloud problem. So the direct observation is so clear that you can see exactly the difference. And we are not talking about the resolution that allow you to see the built-up directly, but through various indices that will allow you to disseminate based on the threshold that, okay, from when you have the result of the indices that is superior to minus 0.25, then you consider it as a built-up area. So not direct observation from the image that you could identify the built-up and the construction. Thank you.
Okay. There's another question by Kavana Abraham.
Cool. Yeah.
Okay. Yes, the same question.
Sorry. Yeah, I just had the same question as Israel. I was wondering if there was a way you could upload a shapefile or GeoJSON data into the platform, into the Jupyter notebook. So I think Sen has already answered that. I was just wondering if you could share that with me as well, or the whole team, for the benefit of the whole team.
Oh, okay. I will just ask Israel if we can get if people can quickly drop the email address here right now that I can save, then I'll send the notebook with you. And that will be so. Now, if you want a quick demonstration, I can as well do that if we still have time. Not on the notebook, but we also have the map platform, which allows you to integrate your SNV shapefile as well directly. Then you will see the shapefile appearing on the map, basically on the location that you have selected. And then you can do your analysis based on that shapefile.
Thank you so much, Adimu. I think our time is up now, and it is very important that we go join the rest of us on the platform, on the main room rather. So we can continue to share the email. I know Adimu can remain here and then be the last person to copy our emails, and maybe in the main session as well, we can send our emails in, and then we will definitely get it. We already have our emails actually. Thank you.